Okay, so this problem asks us to find the amount of excess reagent left over when 100 grams of magnesium chloride reacts with 100 grams of sodium hydroxide. And I've balanced the equation here. So the first thing we have to do is find the limiting reagent. And as we normally do when we start these problems, we need to find out how many moles of each of the reactants that this 100 grams represents. So let's start with magnesium chloride. So for magnesium chloride, we're going to come down here. We're going to say 100 grams times 1 mole is 94.9 grams. I got that from the periodic table. Gives me about 1.05 moles of MgCl2. Okay, I'm going to do the same thing with the other reagent, sodium hydroxide. I'm just going to kind of squeeze it in here and say 100 grams times 1 mole, sorry about that, is, let me see, sodium hydroxide is 23 plus 16 plus 1, which is 40 grams, which equals 2.5 moles of NaOH. All right, so we know how many moles we're starting out for each of them, and then we're going to figure out which of those is a limiting reagent. Okay, so we've established that we have 1.05 moles of magnesium chloride, and we have 2.5 moles of sodium hydroxide. So we're going to determine how many moles of sodium chloride each of these starting reagents would make, and whichever one makes the less amount, that would be the limiting reagent. So let's start out with magnesium chloride, and we're going to look at the molar ratios. So we're going to say 1.05 moles of magnesium chloride over X moles of sodium chloride is equal to whatever we get in the balanced reaction, which is 1 mole MgCl2 for 2 moles of NaCl. And that comes from the 1 that's implied here and the 2 that we get here. And if we solve that for the number of moles of sodium chloride produced from 1.05 moles of magnesium chloride, we get 2.1 moles of NaCl produced from 1.05 moles of magnesium chloride. Now let's try to do the same thing for the 2.5 moles of sodium hydroxide. So 2.5 moles of sodium hydroxide over X moles of NaCl is whatever we have in the problem, 2 moles NaOH for 2 moles NaCl. Now these are both 2, so it's really a 1-to-1 molar ratio. So that will give me 2.5 moles of NaCl produced from 2.5 moles of sodium hydroxide. So because the magnesium chloride only makes 2.1 moles of sodium chloride, whereas the sodium hydroxide makes 2.5 moles of sodium chloride. This is our limiting reagent because it's going to run out. Once we make 2.1 moles of sodium chloride, we're done, and we're going to have excess sodium hydroxide. So now we're going to figure out how much excess sodium hydroxide is left over. Okay, so we've established that we start out with 1.05 moles of magnesium chloride and we make 2.1 moles of sodium chloride. All right, so how much sodium hydroxide do we use? Well, we can see it's a 1-to-2 molar ratio, but let's write the ratio anyway. So 1.05 moles magnesium chloride to X moles sodium hydroxide equals 1 mole magnesium chloride, which is coming from the balanced reaction, over 2 moles sodium hydroxide, which will yield 2.1 moles of sodium hydroxide is used. So the reaction, reaction that's limited by the magnesium chloride only uses 2.1 moles of sodium hydroxide. And if we go back to our original problem, we started with 2.5 moles of sodium hydroxide, if you recall, which will leave us with, well, we start with 2.5, we take away 2.1, and we're left with 0.4 moles of sodium hydroxide left. So 0.4 moles of sodium hydroxide is left times, well, I think we said it was 40 grams, right, per mole, NaOH, which should give me 16 grams of NaOH left. So that's how you calculate how much reagent, excess reagent, is left. And I think we need a smiley face. Okay.